Okay, so what I've got here is just a very nicely formatted version of the decision tree that we just created. I like to do this just to help ensure that we don't make any mistakes. So I actually literally highlight all my input cells with this sickly pink color. So that's going to be cash we have to put into a project or we'll get out of a project, or it's going to be a probability at an event node, a set of probabilities, always adding up to 1. And in blue, I have solution quantities. The software gives us the expected value of the project, assuming we take the decisions that it recommends through the project, which here 1 means take this branch, try for zoning ordinance variance, 2 means take this branch, develop the property. So if we pursued this project over and over and over again in the exact same way, in the long run, on average, if we make these recommended decisions, we'll come up with 9,000. Also, the program gives us the terminal value cache at the end point of each branch, okay? But what we have to compute manually is what's the probability of getting to that branch, okay? So the things to remember with the probability of getting to that branch, once again, are that if we've got a decision that tells us don't follow that branch, the probability is 0, okay? If we've got a live branch, okay, that arises from a recommended decision, how do we get this probability again? We get 56% is equal to our 80% here times our 70% here. And that's because we can multiply like that because the probabilities are independent across stages. And then down here, if we take the sum of the probabilities, we better get to 100, and our expected value is the sum product of what's in this column with what's in this column, as we discussed. Okay, so I'm going to keep moving on here and think a little bit now about what the decision tree is telling us, okay? So as I said, at every branch, it's telling us at the end, on the right-hand side, the net cache we would wind up with by pursuing this project if we get to that node, okay? So for example, if we try for the variance and it gets rejected, we're out 40,000 because it cost us 40,000. Now I'm using thousands units. It cost us 40,000 thousands of dollars to make that happen. So that's our terminal cache here. In this case, we get our 60,000 from minus 40,000, okay, minus 200,000 plus 300,000. That gives us our net 60,000. Okay. So it tells us that. It tells us the decisions that we should make to maximize the expected value of that tree. Okay, and assuming that we make those decisions, it also tells us, as I just showed, the probability of ending at any particular branch. And I've gone over how to compute, for example, things like our probability of getting 60,000 is 56%, but let's just jump back up there and look at that. What that means is the probability of no crash given approval, okay? And we got 56%. That's the terminal node where we get a net of 60,000. And how do we get that 56% probability of winding up there? Our 80% times our 70%. Okay. And it gives us, of course, the expected value of the project, as I said. Which is both computed by the program and checked by us using some product over here. Okay, so here's a little bit more on, just to remind us all, make sure we don't make a mistake, how to compute our terminal path probabilities. So first thing we want to do is exclude any branches where the program is telling us don't take a decision that leads you to that branch. So we set their probabilities to 0, and then we just compute the combined probabilities at every branch. So again, that probability of getting to our 60,000 terminal cache was the probability of no cache given approval. Because of our independence of probabilities across events, that's the same thing as the probability of no crash and approval, and that of course means we just multiply the probabilities and we get to 56%. Also, always want to check that all of our probabilities, when we add them up, get to 100%. Okay, and then to compute the expected value probability, you never want to just believe the software. We want to compute it ourselves over here, up here, and the way to do that is to take this terminal cache times this probability plus 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 this terminal cache times this probability, which in Excel is done with the sum product function that I've showed you, and which in algebraic terms just looks like this summation. Okay, it's really a dot product summation for those the mathematically inclined among us.